is your Weekly Space Hangout for Friday, June 28th, 2013. Joining me this week, we've got Sandy Springman from the Arecibo Observatory. Although, where is your fancy radio telescope background?
I'm sorry, I brought you a fancy jungle background instead.
That's pretty spectacular, actually.
Better than a wall.
Better than a wall. No, it's great. You can just like sit outside in the jungle and report on space news. There's something meta going on here. Amy Shear-Title from Vintage Space.
Hello.
And thank you very much last week for handling the Weekly Space Hangout.
Oh, you're welcome.
Yeah.
Thank you very much for being here to do it this week.
Yeah,
this is almost a repeat.
Yeah,
almost a repeat.
Little smoother.
Yeah, is it a little smoother?
Yeah.
Well, I've probably done 200 of these, so you just have another 199 to catch up. But it's good. It's good. We knew you could. We knew you would handle it with grace and a little rage, and that's what we were hoping for. So.
There was no rage whatsoever.
No rage. She was a consummate professional.
Slick professionalism.
Perfect.
Yeah.
That's great. And David Dickinson, a.k.a. Astro Guys, writer for Universe Today and other places. All right, and this is our team. So now it's going to be a little funny over the summer. Nicole is, I don't know, listening to the radio or something, telescopes, with her headset out. Yeah, everyone's on vacations. It's going to be kind of crazy over the summer. I know Pamela's pretty busy. I know I'm going to be pretty busy, so it's going to be kind of weird over the summer. So I apologize in advance. Things might get a little weird. So this week we're going to talk about what is up with all the smashed moons. The fact that Voyager is almost promised now very soon leaving the solar system. Maybe the planets around Gliese 667c. The return of Shenzhou 10, the PayPal space currency, how people can help search for lunar impacts on the moon, that 10,000 near-Earth objects have been discovered, and that's not many, unfortunately.
Yay.
And, now you can interact with us. This is all interactive. You can make any comments or questions. There's a bunch of places you can do it. First, you can make a comment over on the event page if you're watching this on Google+. You can make a comment on YouTube. You can make a comment on, if you're watching this just in my stream, you can make a comment there. And you can also make a comment on Twitter, although, strangely, the thing that lets me track comments on Twitter isn't working in the Hangout toolbox. So,
yeah, I'm not able to hashtag either.
Yeah, I don't know why I'm not able to sort of follow the hashtag.
I can keep an eye on it.
Just use YouTube. That's all I gotta say now. Like
I have nothing but Google Plus open right now, so if I open Twitter, I'll freeze.
Yeah. So no, not you, David. Please don't have any extra processes running. But yeah, I highly recommend that you go over and just make your comments on YouTube. And while you're on YouTube, go ahead and subscribe wherever that subscribe button is. That way you'll get notifications when this happens next time. All right, so first, so this is funny. So I don't know what it was. Was it Sandy? Someone just before we were getting ready, someone said, "What's with all the smashed moons?" David, I think.
We were talking about, and I had written about Oblivion. I had seen Oblivion at the beginning of the summer blockbuster season. That was the first sighting I had, and that was kind of part of the plot where the Earth's moon had been destroyed. Now, when I went to see Star Trek Into Darkness, I noticed that Kronos had kind of the same thing going on, the Klingon homeworld moon. What did you see when they showed it? But it had a smashed moon orbiting as well. Now, when I saw Man of Steel 2 weeks ago, I noticed Krypton had a smashed moon when they showed the whole sky vista. So that seems to be a sci-fi trope that's going around this summer. That's 3 official smashed moon sightings out there. I know in the Superman mythos there is some precedent for that because it was one of the Kryptonian supervillains, not to geek out too much on DC comic history or anything like that. One of the Kryptonian supervillains that had smashed that moon before. So, but it seems now that if you have a sci-fi movie, you have to have a smashed moon on the horizon there.
I've been watching so many science fiction movies, and I've been waiting for someone to finally present the science correctly.
Yeah.
And I feel like finally we're getting what we need from the movie makers, that that you've got this moon and it's smashed up and there's chunks of debris and it's just floating next to each other in space, just the way it would happen in the real universe, right, Sandy?
That would be
Well, I mean, if you looked at the Krypton's moon, or in Star Trek, the moon getting smashed up, it just sort of looked like it was kind of
Just
in
hanging
process. It was just kind of hanging there, you know, like a Christmas ornament or something. And I don't know, I was watching it with both of my bosses and a number of coworkers, and we came out of the movie theater and we were all like, "What was with that smashed up moon on Cronus? That's not how things should happen."
It's funny that many people notice that.
Okay, so please,
My wife got here on it too.
somebody set the science straight. If you had a smashed up moon, what would it look like?
It depends how long it's been smashed up. Because it probably, if it got hit with something, a big collider, it might never recoalesce. But if it's kind of just fragments like they showed in Oblivion, probably in a year or two, I think it would re-aggregate back into a moon again. You might end up with a ring around the Earth, which would be kind of cool.
Yeah, right. You're gonna get a situation where the thing is, as you said, you know, if it's not very big, if it's, I don't know, if they've shot it with some super duper mining laser and it's kind of torn apart, it's just gonna. I mean, the gravity is just going to pull it right back together again.
I was thinking in Oblivion, if we're dealing with an alien invasion force that can destroy our moon, we're kind of like, it's not even going to be any kind of competition.
Right. So, I mean, a good example of, you know, a moon that is going to be destroyed is Phobos, which is around Mars, yes. And Phobos is rotating within the Roche limit of it, and so the trick is this sort of magical spot. So if you get like the Mars is turning and Phobos is going around Mars, and if you get this situation where Phobos is going faster than Mars rotates, then it's actually starting to spiral inward towards Mars. And at some point within about the next 10 million years or so, the tidal forces on Phobos are going to tear it apart, and it's going to sort of turn into this ring of debris orbiting Mars, and then that ring of debris is going to just kind of come down and lay these awesome crater chains. Yeah.
Phobos is the closest moon orbiting to its primary in the solar system, and it actually rises in the west from as an observer on the Martian surface. It rises in the west and sets in the east because, like you're saying, it actually is going around faster than the planet is rotating. So.
Yeah. So it's pretty amazing to sort of imagine that we exist in this moment in time that we just happen to have this moon. Are you getting like some kind of thunderstorm in the background, Sandy? That's awesome.
Why, yes, I am.
So you can imagine, you know,
in the jungle.
It's amazing when you think about amazing coincidences, right? We have the coincidence that the moon and the sun are the same size in the sky for us, and
in this epoch.
Yeah, no, just coincidence, right?
Yeah.
And we have the coincidence that we happen to see Phobos, because
in just a little over 1 billion years, the moon is receding from us, and in a little over 1 billion years, we won't have total solar eclipses anymore. We live in that current epoch in time right now where the moon can cover the sun about 40% of the time. A lot of times, like this past eclipse was annular, it was too small. Yeah. So we don't always get total solar eclipses anymore either right now.
So any sci-fi writers now, movie scripters wanting to show a smashed moon,
I'm available for consultation. Just throwing that out there.
Don't do it. Just,
it looked
you know
too
what?
tidy. It looked too neat. I think it would be a lot more of a mess.
Yeah,
Oblivion did the best. I'm not a dynamicist. I'm not a theorist. You'd have to ask my office mate, but he would give you a more straight answer.
If you could look into that, that would be great. All right. Moving on. So let's talk about the big news. Has got to be the planets around. We all pronounce it now. I've forgotten. I'm going to have this lovely German
Gliese.
I'm going to have this. I had this nice German lady tell me how to say it, and now I've lost it. Gliese. 6.
You'd think with my last name I would be able to pronounce these sort of words, but nope.
So Amy, I know you reported on it, right?
Yeah, I did a little bit about it, and I sort of put it in the context of finding interesting planets around red dwarf stars, which is sort of not unheard of, but it's pretty rare. So the big discovery is that around this, and now I'm going to say it wrong, there is a triple star system called, I guess actually it's the system called Gliese, because the 3 stars are Gliese 6, 6, 7, A, B, and C. And around the star C, which is actually the smaller and dimmer of the 3. They found 3 I don't know who they are off the top of my head, some very clever people found 3 potentially habitable planets orbiting in that star's habitable zone. So that's pretty significant, because you wouldn't expect a red dwarf necessarily to have a big habitable zone to actually hold 3 planets, and these 3 planets are taking up most of the star's habitable zone. But that's pretty big and pretty cool, and you get to, were you to go to one of these planets, you would see 3 suns setting in the sky. The main star would be big, and the other 2 would look kind of like the moon, which, as we just discussed, are the same size in our sky. So that's coming off the heels, and this is what I think is kind of neat, is this is coming off the heels of the red dwarf star TW Hydrae, around which astronomers found a gap in its protoplanetary disk that suggests there's another planet forming really far from this star. Again, another red dwarf star, which is kind of interesting, because they're not the typical stars that you see not only forming planets, but in the case of Gliese, forming habitable planets.
So we still haven't quite found the Holy Grail yet. We haven't got the Earth-sized world in a habitable zone.
No, these two planets, or these 3 planets rather, are bigger than they're bigger than the Earth. I'm not sure how much bigger, but sorry.
Yeah, bigger.
Sorry, phone.
Yeah, and that's what we're expecting.
So they're significantly bigger than the Earth. There's 2 or 3 times the mass, the size of the Earth. So we're still far from getting that perfect planet, but this is a step closer. And every time we find something like this, some really interesting looking planet in a habitable zone around a star that you wouldn't expect to find it around, it sort of broadens the scope of where we can be looking for exoplanets. And that's what's really neat about this, is that this is kind of changing the way we look for exoplanets. So as we keep digging through Kepler's data, because the mission is not dead yet, and whatever comes next, there's just going to be more places to look for this twin Earth, or evil Earth twin, I don't know.
Well, it's kind of bittersweet when you think about the loss of Kepler at the same time, right? I mean, we've lost the planet hunting machine that was turning up a lot of these planets.
Yeah, but there's still, they, in the press conference, I guess it was like 2 months ago now or something, they did say that they have terabytes worth of data still to go through, and that's significant. They've gone through, yeah. It's not like I read this somewhere, because I like the idea of Kepler being a pirate, of just pointing and saying planet. Oh, that's not what happens, right? It takes this light data and looks at the interference patterns, and astronomers are the ones looking through the data to find things. So there's still tons of stuff to do until we get another telescope up there, and there's also Hubble. So I wouldn't call it like. It's sad, but we're still doing stuff with it, which is kind of neat.
No, it's all sad.
All sad all the way down.
Yeah. Well,
you have the saddest worldview.
Yeah. Well, no, I am really a big fan of solving the most interesting scientific question that we could possibly ask, which is there life in the universe? So, this is one step along that path. And so if we lose Kepler, and now, the other piece of news this week was that they're shutting down the Corot telescope. They've lost that. So that's the other planet hunting telescope. So now 2 planet hunting telescopes are down.
TESS is the next one in the pipeline, and that's not till 2017, I believe.
Right.
Will be the next EXOS. That's going to be the Kepler successor. So
yeah. So it's great that there is a successor in the pipeline, and there should be more of these, and that's great. It is, because the big problem with Kepler and with these kinds of planet hunting, to find an Earth-sized world in the habitable zone around a sun-like star, you need to wait a year for it to make a transit in front of the planet, in front of the star, and that's your first one. So you don't know how long that one took, and then you have to wait another year, and then you get another one. Well, maybe you've seen it, but maybe you haven't. So you got to wait a third year to really confirm your data. Ideally, 4 years or 5 years, and and that pushed. And now Kepler's not going to be able to provide that level of data.
There's Arcid too, if it gets its 2 million.
Yeah. Sonny, you've been tracking Arcid. How is Arcid doing?
And the cat just ran. The cat just ran off with my headphones.
Good.
Cat got your.
I just gave Arcid my I just gave Arkad my 25 shekels there an hour or two ago. So.
Yeah,
25 shekels divided by 4. That's what?
I paid.
I don't know what the exchange rate is these days.
I paid my 25. I want my selfie.
Yeah, I'm looking forward to my selfies in space in a while. So they're hoping for a stretch goal of 1.7 million. They're at 1.25 million right now, which is pretty exciting. So there've been a lot of they've made a lot of their stretch goals, including number of donors, but they're also hoping to do an asteroid zoo project. So if they get 1.7 million, they'll create a new project on Zooniverse for people to find potentially hazardous asteroids from Catalina Sky Survey data. I've always wanted to discover an asteroid.
Oh, cool.
I would really love to have an asteroid. You can't name it if you discover it, but you can name it after someone else. And I think that would be tons of fun.
You can't, if you discover an asteroid, you can't name it after yourself?
No, and you can't name it after a pet either. Someone named an asteroid that he discovered Mr. Spock after his cat, who was inquisitive and had pointy ears. The IAU did not like that. So you cannot name asteroids after pets anymore. Because that's what he said in the citation.
They know. They figured out.
The IAU knows everything.
Yeah. So here, I don't know if this is coming through. So you can see the different stretch goals they've got. So they've passed the 1 million. The extra ground station of the 1.3 million, a beta selfie of the 1.5 million, and then partnering up with Asteroid Zoo at 1.7 million.
And then less than $50,000 more dollars, they'll have an extra ground station, so it'll be easier to download data faster. And
that closes this Sunday.
And that's in 54. It closes in 54 hours, so June 30th.
So if this is going to sort of go the way we've seen them before, that's probably the number they're going to get is the 1.3. It's going to be hard just to wrap that up in 57 hours. Yeah, I mean,
they've been pretty persistent. They've been doing Hangouts. Yep. They did a, what's the word I'm looking for? They did a Ask Me Anything on Reddit with all of their engineers, so people were asking them questions, and they talked about, what's that, that app, the something orbit. They said their engineers learned everything they knew about orbit mechanics from the Space Command app.
Oh, the Eyes on the Solar System one?
No, it starts with a K. It's a game.
Oh, Kerbal Space Program?
Yes. They said one of their engineers learned everything he knows about orbital mechanics from the Kerbal Space Program.
I've heard that's a fun game. I got to give that a try at some point. Get the kids into it. Yeah. So I mean, if you're watching this right now and you've got some extra money and you want to pitch in, then by all means, I will destroy my journalistic integrity and go help donate to get the Space Telescope built and extra ground stations and participating in extra solar planet research. That would be fantastic.
If they get to 2 million, that would be pretty cool. I doubt they're going to get to 2 million by Sunday, but you never know with these things. So.
I'm surprised that they didn't make more money than they did, actually. I mean, they did a really great job of promoting it. If they had sort of put me in charge of promoting it, I don't.
We wrote a lot of articles about them.
We did. Well, no, I know. I mean, they definitely sort of somehow co-opted me into helping them promote it. But I think if I can't imagine, I wouldn't have been able to promote this any better. They did a fantastic job. They did tons of reaching out, tons of outreach, lots of video, lots of updates. It was all really great, and I'm
once it gets out into space, who knows how it might be used? I mean, they once it's there and in space, they may use it for exoplanet hunting anyway.
Yeah, well, I mean, the thing is the real mission is $4 million, right? And this is just the beginning. There's going to be multiple telescopes going up. I think, everyone's just waiting to see if they can actually get this thing in space for the price that they're saying. And then, you can imagine lots of research institutions and universities that have various projects buying time on these telescopes at a fraction of the price that they might have to pay if they're going to go through Kepler or something like that. So you can imagine, if they can actually do this and sustain it, then you're going to start to see, I think, hopefully this will make a lot more research at a lot more reasonable price. In Canada, we've got the MOST telescope.
MOST, yes.
MOST, yeah.
At MOST and MOST, yep.
Yeah, and they call it the Humble Space Telescope because the thing cost $8 million to launch, and it's a,
I have come across it.
Yeah, a friend of mine, Jamie Matthews, out of Vancouver, sort of runs the program, and it's it's a reasonable price. It does a very specific job, but it's and it was $8 million, and it's I don't think it's going to be anywhere near as capable as what these are. So I think this is a great time. I think this
Arcade
yeah
will be a SpaceX Falcon 2 launch too.
Yeah, well, the two really go together, peanut butter and jam. So, okay, well, and speaking of the need to discover things in space, Sandy, you have discovered 10,000 near-Earth asteroids.
Well, the greater asteroid community has discovered over 10,000 near-Earth asteroids. We don't discover them. We follow up with radar. We are absolutely not a discovery tool at Arecibo Observatory. But U.S. resources have discovered over 98% of near-Earth asteroids, which is kind of exciting. We're at 10,000 these days, and a lot of them have been discovered by robotic surveys. Catalina Sky Survey, Linear, based in New Mexico, and then this Project Pan-STARRS is coming online in Hawaii. So this is really exciting. 10,000, that's an awful lot of...
Oh, you've lost your audio there. Oh, there we go.
There's about 300,000 asteroids overall that have been discovered so far, which is a lot, and we're expecting that there's another 90,000 near-Earth objects out there waiting to be discovered.
So what size are we talking about here?
Sorry?
How big are these asteroids?
I mean, they're, anything from the, meters to tens of kilometers. This morning we were looking at something the size of a dinosaur killer, 9 kilometers across. So you get really, quite the variety of size of these near-Earth objects. So yeah, one that's, 5 meters across, it's not going to ruin your day. NASA can probably bring it home on a leash.
Yeah.
You're a good asteroid. You're a good asteroid.
Yeah, it'll explode above the atmosphere in Russia, maybe.
Or wherever.
Yeah.
People are like, why? People who will not
came at us out of the sun.
Why don't they, blow up over DC? It's like, well, that's where our funding comes from, in case you didn't notice.
Yeah.
So, these larger ones would really, cause global devastation. Smaller ones, a couple kilometers across. If you have a 1 kilometer asteroid that hits the Earth, it's going to create a 10-kilometer crater. And gosh, it's going to churn up a lot of stuff into the atmosphere. It's going, could cause earthquakes, tsunamis, all sorts of unpleasantries. So really, it's important to find these things before they find us. So there's this asteroid grand challenge coming online, and the European Space Agency has a new NEO coordination center, spelled the European way. So there's more money going into surveys, and NASA's really hoping to find most of the dangerous near-Earth objects by 2020.
So by 2020, we could pretty much know where every single dangerous asteroid in the entire solar system is, like the near-Earth objects, and have sort of worked out the Torino scale for all of them, right?
Yeah. So the Torino scale is an idea of how hazardous an object would be if it hit the Earth based on its size, and then also the frequency of impact of an object of that size. So you have things the size of Tunguska every, so many years. You have dinosaur killers every in the tens of million years, and then the little 5-meter ones all the time coming through the atmosphere. So that's what the Torino scale is.
And right, and so we could say, well, you know what? We don't even need to do any kind of asteroid program because we're safe for the next 300 years. Or, we've got these very risky objects, and we're going to need to get on them.
I think I see a lot of people don't always understand is that the predictions get less uncertain the further you go out in time, as far as things disturb things in their orbit. So all these predictions are kind of they're more accurate the closer in that we see something coming by.
Yeah, right now we're pretty confident the next couple of decades we're okay. Yeah. But once you get into the 2030s, 2050s, there are some objects that might come, ruin your day. And anything bigger than 500 feet. That's enough to level a city. That would be a 5-kilometer crater.
That's not a good day.
No, that would really stink. I mean, and 500 feet, if you've seen photos of Arecibo Observatory, that's about the distance from the platform to the bottom of the dish. Which,
that's big.
Gosh, that's big, but that's also kind of small. Kinetic energy is just sort of harsh.
Yeah, and I know there's lots of proposals to put together space-based telescopes that will actually, contribute to this discovery as well. So I think
like ARCID.
Like ARCID, right? And other ones. I know NASA has from various times put ideas in circulation for doing that as well. So,
that's what this Asteroid Grand Challenge is about: better ways to find things, deflection techniques, sort of.
Have you looked into? Did you guys talk about the Grand Challenge last week? I didn't.
We did talk about that.
Okay.
A bit.
All right. Okay. I didn't want to bring that topic up again. I figured you guys would have talked about that. So, okay, cool. All right. So, I'm Amy. Do you want to talk about Voyager leaving the solar system again? Maybe, probably.
Yeah, maybe.
For 2013.
Possibly. This year's possibly false start for Voyager leaving the solar system. So yeah, Voyager might be leaving the solar system again. So sort of like the old news that keeps being new news because it is really cool. So Voyager was launched in September of 1977, and it whipped by Jupiter and then Saturn, and Saturn's gravity sort of popped it up out of the plane where all the planets orbit. So it just kind of started heading towards interplanetary space, and it's been going for 33 years since that happened. Yes, I can math. 33 years since it left Saturn in December of 1980. And it's getting into this really kind of murky region towards the edge of the solar system, and there's kind of this boundary called the heliosphere that is created by the charged particles of solar wind. So once it leaves those charged particles and gets into cosmic ray particles that generally can't get past that barrier, that will be when it's in interplanetary space. However, it's very hard to figure out when that's going to happen, or even figure out when it happens, because it's in this space right now called the magnetic highway, where charged particles from the solar wind and charged particles from cosmic rays are passing past each other, but they're lined up along the magnetic field of the sun. So Voyager is sampling some interplanetary space stuff, but it's not there yet because it's still sampling enough solar system wind stuff. So it's getting closer, and that's pretty cool, but it's not quite there yet. So what astronomers or the mission team is looking for, there's kind of there's going to be, they think, there's going to be a very abrupt change in the direction of the magnetic field that Voyager is experiencing and registering, and that would indicate the presence of proper interstellar magnetic field that is out of the solar system, and we have finally, 36 years later, or however long it is at that point, reached interplanetary space. So it might be, months or years, or it could be tomorrow, but I don't know. It's kind of, it's still a 36-year-old spacecraft that's 11 billion miles away right now, and it's still talking to the Earth, and that is so cool.
Well, I think one of the things that's great about this is that it's running this RTG nuclear. Yes. I mean, it's not really a nuclear plant, but it's running this thermal, plutonium thermal reactor. Not really a reactor. Anyway, but the point is that it's showing you how long these things last, and this is what's inside Curiosity, and this is what's inside New Horizons. So we've got, I think, a lot of years ahead for these spacecraft, and I'm really glad they're starting to build the program again to put these into future spacecraft. So
because I think the last I saw, and if I'm wrong on this, correct me someone, but I think Voyager has enough power in its RTG to power it through at least 2020, at which point they're going to have to start shutting down. They have, some instruments have failed and they have had to shut some stuff down, but I think at 2020 it's going to be the point where it starts to get a little bit critical to shut down some things to conserve what remaining power there is. So that's going to be a very long-lasting RTG. So if,
off the top of my head, I think plutonium-238, what's in it, is the half-life is 77 years. I'm pretty certain, just without looking it up on Wikipedia.
Nice.
That's a little piece of knowledge to know.
Unless you're wrong.
Unless you're wrong.
Well, within a few years, I think 77, it may be 75, 78 for 238. That's not the weaponized stuff. The weaponized stuff is 239. It's a different isotope. Right. But it's that means it will be at 50% power after 77 years of use. And if any alien civilization finds that RTG, they could actually date when that plutonium was manufactured by looking at its half-life. It would be an easy mathematical calculation for anybody that knows anything about half-life, which presumably they would know.
But I wonder if, it's 78,000 years for Voyager to get to the nearest star system, and not even it's pointed at the nearest star system. So,
No, it's not.
You could imagine we're going to be having this conversation again in 200 years. Like, Voyager's just almost left the heliopause into intergalactic, but yeah. So a couple of comments here. Hugo Burnham says, will the asteroids, this is back to the asteroid conversation, will the asteroids that are captured for mining be included? So, your asteroid on a leash, Sandy, will that be counted?
Counted in the what? In the 10,000?
Yeah, in the 10,000, in the all of the ones that need to be counted, yeah.
I think those will be. Well, those will be smaller than 500 feet, 140 meters. So they're not part of the ones that NASA is trying to find. They're not one of the city levelers, but they'll be counted in the total near-Earth object population. But those are the ones that NASA is going to bring home that are the size of a school bus or the swimming pool that we have at the observatory or the size of your car. I'm really not worried.
That's a lot of new asteroids needing names.
Well, linear ones don't get names, which is really. I mean, there's one program though that if you win the Intel Science Fair Challenge as a high school student, you can get an asteroid named after you. So I have a bunch of friends who have asteroids, which is infuriating because they've never done a lick of asteroid research, and I've been looking at rocks in space for over 8 years now. I really want an asteroid.
It's pretty great.
I know somebody here does.
Yeah, I have an asteroid named after me. Okay. There was, let's see. So Rob Kroll says, we found out more and more star systems a long time ago in a Isaac Asimov story. And he wasn't sure what the name was. It was Nadieski Nosi.
And Isaac Asimov wrote a lot of stories.
Yeah, but that sounds like Nightfall. That sounds like, I think the story he's talking about is Nightfall. Right? Yeah, Nightfall is a great story. I like the short story better than the book part, but the gist is that this is a star that's in sort of close to the galactic core, and so it's got it's in a globular star cluster. Yeah, and it's got tons and tons of stars in the sky, except for one night, an astronomer has figured out that they're going to all be down at the same time or be in transit or get eclipsed, and there will be no stars in the sky or no suns for one night or for a few hours, and predicts that everyone's going to go crazy because they don't know what it means.
They can't figure out why their civilization collapses every 20,000 years until they realize it's like, because we only have night once every 20,000 years.
Right, exactly. And I thought it's a great. The short story was good because I don't know. It's one of those things. You get this great idea, and then you don't need to necessarily turn it into a book. So, okay, let's move on. The Return of Shenzhou 10, David.
Yes, the space population went down by 3 again earlier this week when 3 takonauts or astronauts, depending on how you want to phrase the terminology, returned to Earth Wednesday, early Wednesday morning Chinese time, Central China time, 8:07 a.m. local. It was about midnight UTC, about 8 o'clock Tuesday evening, and they actually showed the whole thing on CCTV when they returned. They were on a 15-day mission. This was the second mission to Tiangong-1, and this is the last mission they're doing. Tiangong-1 was kind of a proof of concept thing that the Chinese did. Leading up to their new space station that they want to get up there, kind of like a Mir Redux that they want to put up by 2020. It's going to be kind of a modular, they're going to launch a core, and then they're going to have all these kind of mini Tiangong modules that are going to hook to it, kind of like a big Lego space station. They don't have a shuttle or anything to assemble it with. There is the photo.
I love this picture.
If you look closely in the back, and it was interesting when we watched the video play when they actually came down, the module actually was drug. You can see it there on the press.
Yeah.
It actually was drug quite a ways across. I'd never seen that on a Soyuz landing there. I don't know what the difference is with their the Shenzhou modules, but they always seem to hit pretty hard when they land. They have I don't know if they have an issue with their retro rockets. I'm just kind of speculating or what it is, but it hit, and then we actually saw that it looked very War of the Worlds with it laying there on the on the tundra just for a bit with that big drag mark behind it, like it had come in hot or something like that. It was smoking, and there was this big drag mark in behind it.
But it's not like they hooked up a tractor and moved it. It was like maybe the parachutes were still open and high wind or something, and just pulled it along.
I think it looked pretty windy that day. It was on the Inner Mongolia there in northern China where they landed, and I think the parachute might have just drug away before it finally detached. But they all got out fine, and it was interesting to watch. I was surprised not many people were watching on CCTV on the re-entry, and because they followed the whole thing in just like the Soyuz landing in it. And I was actually out watching for a pass of Shenzhou and Tiangong the morning before when they undocked. I didn't see the taconauts, but I saw the Tiangong when it went by that morning. We had some visual passes, so that was kind of cool to see. It's still up there. It's going to be up there until late 2013. They haven't got a final date when they're going to deorbit, but they think they're definitely going to deorbit their space station pretty soon. So in the next couple of years, they're going to assume assembling their new as of yet unnamed space station.
Look at I like this picture here. They're just bringing their space chairs over so they can sit down, and I don't know. It was just the way that whole thing was framed. It was quite something.
And the one teacher that went up there, I forget her name. She actually gave an entire lesson. I watched it on CCTV. They broadcast it later on
really?
G. And she kind of given Commander Hetfield some competition, I thought, there. So it was actually kind of a good little space lesson that they did that all the students in China followed along. And it was kind of interesting to watch. It's all up there. It's probably on YouTube archive now, but it was kind of interesting.
That's really cool. Hugo Burnham noted that RTGs use 238 plutonium, which decays with a half-life of 87.7 years.
That was off by 10.
There you go. You're off by 10. And also, Hugo wanted to know, did they carry the deck chairs into orbit with them? And clearly you could see these deck chairs were brought by
were brought in,
by the ground support. Yeah.
It's interesting with the Soyuz one too to watch when they go up and do the opening and everything. It's really, and we talked about, I think, this last week, where all this stuff with the Chinese space programs and the Russian space programs a few decades ago, being a child of the Cold War, that all went on in secret. So it's really fascinating to me to be able to. They have that access where we're getting to see how they operate and how they do things now, and it's pretty interesting to watch.
Yeah. Okay, so we've talked about that. Okay, so let's talk about PayPal's new service, and I will sort of read out a little bit here so we can get up to speed. So it's called PayPal Galactic. And so this is PayPal's teaming up with
payments in space.
In space, yeah.
Aren't they already going to space? You transfer money and it goes to a satellite and back down or something. I mean, come on.
But if you are in space and you don't have any cash and you can't hit a bank machine, how will you pay? And this
because
is the
movie
problem.
Theaters in space only take cash.
They only take cash. Yeah, exactly. So they've partnered up. PayPal's partnered up with SETI Institute people to come up with PayPal Galactic, which is just like PayPal but for space payments. Now that sounds crazy, but it's
here's
important.
my email address. So pay me maybe.
Perfect. Right, so here's just a little quote here. So as space tourism programs are opening space travel to the rest of us, this drives questions about the commercialization of space. We are launching PayPal Galactic in conjunction with leaders in the scientific community to increase public awareness of the important questions that need to be addressed. We may not answer these questions today or even this year, but one thing is clear, we won't be using cash in space. PayPal has already pushed payments onto the internet, onto phones, and across terrestrial borders. We look forward to pushing payments from our world to the next and beyond.
So now if we find an ET signal, we can just paywall them and say, if you want to hear more, click here.
If you want to hear more, click here, yeah. Yeah, this sounds like a kind of publicity experiment to me, but...
Well, it's probably going to be great for the SETI Institute.
Yeah, absolutely. So great going for the folks at the SETI Institute. I just, how long will it be? Just imagine all of the things that need to be figured out before this part gets done. You need to have,
living.
I don't know, a way to launch people into space inexpensively. You need a place where people can go and survive and not die in space. You need a way to resupply them. You need some way to, get up get goods into space that they wish to purchase. No, I understand. I understand.
No, it's good.
This is capacity. This is infrastructure. This is anticipating needs. This is.
Yeah.
Space elevator.
In the larger scale, I think I appreciate things like this, and I also think it's really cool that in Silicon Valley there's not necessarily a lot of communication between the space sort of and the astronomy groups and startups and sort of more the technology, internet-based companies. So I think this is really good that they're starting to form partnerships between a group like SETI and PayPal. Even though I try to avoid PayPal as much as possible, they're not particularly kind to a lot of small businesses. But in theory, I think this is sort of how things will be going, and I think this is a good start.
Yeah, so. I mean, they can. Everybody does what they can, and if you're Elon Musk and you're building super awesome space rockets, then that's what you do. And if you're Bigelow and you're making space hotels, and if you're PayPal, then you figure out how people will pay for their space rockets and space hotels, and return flights from space.
If they partner with Bitcoin, then it'd be all over.
yeah, we can't have that.
So some small businesses are taking Bitcoin as a way to sort of differentiate themselves from the crowd. But let's not get into Bitcoin.
Yeah. Okay. So anyway, yeah. So I just think why not? Like, I'm not going to stop them from having this conversation and working out the infrastructure. I suspect there's not going to be a lot that'll get done until we have the the rockets and the hotels and the things that people want to buy in space. So. Okay, cool. So I guess the last conversation, this is something you worked on, David, was just a call for amateurs to help search for lunar impacts.
Yeah, and it's interesting that actually we're entering into that phase of the moon right now, where toward last quarter phase, where what they're doing is they're actually doing high-speed video aimed at the moon, and NASA's been doing this for some time and looking for meteor shower impacts on the moon. And this kind of tied in with the Lunar Dust Explorer that's going up Laddie. And September 5th, it's launching out of NASA Wallops. And it's going to be a pretty spectacular night launch, by the way. A lot of the East Coast will see it. But it's the American Lunar Planetary Association has a call out there for amateurs that have these high-speed video rigs to possibly try to video and look for impacts on the moon. Trying to characterize things like the Perseids are coming up in August, the Taurids are peaking right now, and there was an impact earlier this year in March that was a big high-profile impact that NASA had caught, I think March 15th or so. And incidentally, if you don't have a high-speed rig that is kind of geared toward doing this sort of thing, the International Meteor Association is always looking for people to do meteor counts, because whatever's hitting on that dark side of the moon is generally streams that the Earth is entering into as well. And those kind of counts don't take anything but just going out and noting how many meteors you see and doing a report. I've done those sorts of things. I'm usually doing on any of the larger showers like the Leonids or the Perseids. I'm out there just the Eta Aquariids is another one coming up. I'm just out there counting per hour. 10 meteors per hour is about my level of interest. If it's weaker than that, I usually pack it in and do something else. If a meteor shower like the Geminids last year was a pretty active shower, and I was in a dark sky location out in North Carolina, so I stayed out there most of the night watching those. So those are ways that amateurs can contribute to an upcoming mission.
And there was a video just a couple of months back, right, where someone actually captured a little puff of flash of light.
Yeah, that was the one in March. That was the one that NASA caught. We wrote about that. There was an impact. These, like I said, are on the dark side of the moon, which is different than a lot of people kind of confuse the far side and the dark side. When we're seeing the moon toward crescent in first quarter phase, we're seeing that unlit dark time, nighttime side of the moon. The moon is in tidal lock, so 1 day there is equal to one synodic period, which is like 29.5 days. But that dark side of the moon is where you're going to see these impacts. Now, these micrometeoroid impacts, they're very fast and very faint, and they're getting glared out by that brighter crescent phase of the moon. So they're going to show up on video impact. It would have to be a big impact for you to see visually. Those kind of impacts don't happen often. And there's actually a program called Lunar Scan that's in association with that one project that will actually take and scan through video frames looking for high-speed impacts. It will do it automatically. It was a NASA engineer that designed this. And I've used Lunar Scan before. I did a whole video sequence while I was imaging the total lunar eclipse in 2010, in December 21st. And I used lunar scan because the Geminids and the Ursid meteors were active at that time. And there's some discussion of whether during that total lunar eclipse we were going to see impact flashes. It's worth a try. I didn't see anything, but I used lunar scan to comb through all my video just to see if I hadn't caught anything of interest during it. Would be cool to catch, and it's not out of the question, during a dark lunar eclipse to catch an impact during the eclipse would be kind of cool. I don't know if that's been done yet.
I don't know. It could be you.
Yeah. It's always worth watching for these kind of things.
Okay, well, I think we're reaching the sort of end of our time, and we're all out of stories, so I'm going to say goodbye and thank people for participating. And also find out where we can learn more. So, Sandy, where can people find more Sandy?
I am on Twitter at SONDY.
You must have started pretty early.
Yes and
no. You got a
no.
short handle.
I've been on Twitter since I think spring 2006, but not with that handle. I know someone at Twitter, and she gave me that. So that was very kind of her in the last couple of months, actually. I
started up right at the beginning, but didn't think to get Fraser. I probably could have gotten at Fraser if it even occurred to me. But I got F. Kane.
Live and learn.
I know.
I do have Sandy.com, and I've had that since 2000.
Oh, okay.
99.
That's pretty good too. That would have gone. But yeah. So, and you are, I'm
at Arecibo Observatory. There are a lot of very incoherent posts about asteroids right now because our observing schedule really makes no sense. We've been, I think, Wednesday night, we were up from 10 p.m. until 7 a.m. This morning we were observing from 3 a.m. until 7 a.m. And then tomorrow we're on from 8:30 in the morning until 4:30 in the afternoon. So if you want to watch the slow descent into madness.
Yeah. Well, I mean, I thought radio astronomers get to, they get to observe during the day like a regular human being.
Observe during the day. It's really strange to be in the control room when it's light out. But that doesn't mean that the asteroids are necessarily up in the middle of the day. Sometimes they're up at night.
Right.
You guys don't get clouded out. That's kind of cool.
We do not get clouded out, but occasionally when there's a lightning storm that rolls in, the tie downs for the telescope have to be turned off because if lightning strikes the motors, it'll break them. So we do have other problems.
Right.
But we can observe. Radar's like the honey badger; it simply doesn't care. We observe
during
the day. We observe during the rain. I wrote a blog post recently for the Planetary Society about how radar, actually, the engineering side, doesn't care and how it works. So if you want to read that, there's a honey badger reference.
There we go. Amy, share title.
I am AST Vintage Space on Twitter, and my blog is also called Vintage Space. You can Google it because my name can be hard to spell. I'm also at Discovery News, Al Jazeera English, Motherboard Device, Scientific American, and I think that's it. And the Google Pluses and Facebook. All space history all the time.
I have described you as the hardest working woman in space journalism.
Too kind.
Yeah. Also the biggest space nerd. So just as long as I'm also unkind.
Unfortunately, all of my models are not places you can see them from my computer anymore.
If you could get those set up, that would really contribute to the sort of background.
I'll do what I can, Fraser.
All right. David Dixon, where do we find more of your writing?
I am at AstroGuys with a Z across all platforms, and when it's cloudy out, you can find me writing at Universe Today, my own site, astroguys.com, writing curriculum, science curriculum for Schmoop, Listosaur, and wherever else I might pop up. Those are my primary sites.
Fantastic. And also you join us regularly on the Virtual Star Party, which is great.
Yes, I am in the Virtual Star Party.
Hugo Burnham just posted something funny on the event page, but I'm not going to say it on this show. And as I mentioned, I am the publisher of Universe Today. I don't write so much on Universe Today anymore, but I still publish it. I'm still pulling the strings. But I have been doing a lot of sort of video stuff on YouTube, which is kind of fun. And they're
really good too.
Thank you.
Yeah, really good.
Those are pretty cool.
I try to figure this stuff out. So if you want to watch those, they're the ones with the little pictures in my YouTube stream, and so you can subscribe wherever the subscribe button is, And if you have a suggestion for a topic you want me to cover, I'd be glad to do that. Yeah. So the next thing we're going to do is going to be the virtual star party on Sunday night. I'm not going to be there, so it's going to be the Scott. Scott's going to be running the show with the astronomers. I'm going to be at a wedding, so
I will bring Saturn, weather willing.
Nice, nice. Now is the time for Saturn.
That's the big if.
Well, thanks everybody for watching. Thanks for the team for joining us this week. I really appreciate it, and we'll see you all next week.
Bye.
Anything like that. One of the Kryptonian supervillains that had smashed that moon before. So, but it seems now that if you have a sci-fi movie, you have to have a smashed moon on the horizon there.
You know, I've been watching so many science fiction movies, and I've been waiting for someone to finally present the science correctly.
Yeah.
And I feel like finally we're getting what we need from the movie makers, that that you've got this moon and it's smashed up and there's chunks of debris and it's just floating next to each other in space, just the way it would happen in the real universe, right?
That would be.
Well, I mean, if you looked at the Krypton's moon, or in Star Trek, the moon getting smashed up, it just sort of looked like it was kind of just in process. There. It was just kind of hanging there, like a Christmas ornament or something. And I don't know. I was watching it with both of my bosses and a number of coworkers, and we came out of the movie theater, and we were all like, "What was with that smashed up moon on Cronus? That's not how things should happen."
It's funny that many people notice that.
Okay, so please,
my wife got here on it too.
Somebody set the science straight. Help search for lunar impacts on the moon, that 10,000 near-Earth objects have been discovered, and that's not many, unfortunately.
Yay.
And, yeah. Now, you can interact with us. This is all interactive. You can make any comments or questions. There's a bunch of places you can do it. First, you can make a comment over on the event page if you're watching this on Google+. You can make a comment on YouTube. You can make a comment on, if you're watching this just in my stream, you can make a comment there. And you can also make a comment on Twitter, although, strangely, the thing that lets me track comments on Twitter isn't working in the Hangout toolbox. So,
yeah, I'm not able to hashtag either.
Yeah, I don't know why I'm not able to sort of follow the hashtag.
I can keep an eye on it.
Just use YouTube. That's all I gotta say now. Like
I have nothing but Google Plus open right now. So if I open Twitter, I'll freeze.
Yeah. So no, not you, David. Please don't have any extra processes running. But yeah, I highly recommend that you go over and just make your comments on YouTube. And while you're on YouTube, go ahead. This is your Weekly Space Hangout for Friday, June 28th, 2013. Joining me this week, we've got Sandy Springman from the Arecibo Observatory. Although, where is your fancy radio telescope background?
I'm sorry, I brought you a fancy jungle background instead.
That's pretty spiffy.
Oh, that's kind of cool.
Better than a wall.
Better than a wall. No, it's great. You can just like sit outside in the jungle and report on space news. There's something meta going on here. Amy Shear Title from Vintage Space.
Hello.
And thank you very much last week for handling the Weekly Space Hangout.
Oh, you're welcome.
Yeah.
Thank you very much for being here to do it this week.
Yeah.
This is almost a repeat.
Yeah,
almost a repeat.
Little smoother.
Yeah, is it a little smoother?
Yeah.
Well, I've probably done 200 of these, so
Yes.
you just have another 199 to catch up. But it's good. It's good.
I look
We
forward
knew
to
you
it.
could. We knew you would handle it with grace and a little rage, and that's what we were hoping for. So subscribe wherever that subscribe button is. That way you'll get notifications when this happens next time. All right. So first, so this is funny. So I don't know what it was. Was it Sandy? Someone just before we were getting ready, someone said, "What's with all the smashed moons?" David, I think.
We were talking about, and I had written about Oblivion. I had seen Oblivion at the beginning of the summer blockbuster season. That was the first sighting I had, and that was kind of part of the plot where the Earth's moon had been destroyed. Now, when I went to see Star Trek Into Darkness, I noticed that Kronos had kind of the same thing going on, the Klingon homeworld moon. What did you see when they showed it? But it had a smashed moon orbiting as well. Now, when I saw Man of Steel 2 weeks ago, I noticed Krypton had a smashed moon when they showed the whole sky vista. So that seems to be a sci-fi trope that's going around this summer. That's 3 official smashed moon sightings out there. I know in the Superman mythos there is some precedent for that because it was one of the Kryptonian supervillains, not to geek out too much on DC comic history.
There was no rage whatsoever.
No rage.
No
She was a
rage.
consummate
Slick
professional.
professionalism.
Perfect.
Yeah.
That's great. And David Dickinson, a.k.a.
Hey.
Astro Guys, writer
We're
for
here.
Universe Today and other places. All right, and this is our team. So now it's going to be a little funny over the summer. Nicole is, I don't know, listening to the radio or something, telescopes, with her headset
Everybody's on
out.
vacation.
Yeah, everyone's on vacations. It's going to be kind of crazy over the summer. I know Pamela's pretty busy. I know I'm going to be pretty busy, so it's going to be kind of weird over the summer. So I apologize in advance. Things might get a little weird. So this week, we're gonna talk about what is up with all the smashed moons. The fact that Voyager is almost promised now very soon leaving the solar system. Maybe the planets around Gliese 667c. The return of Shenzhou 10. The PayPal space currency. How people can